All right. All right. Today we'll be doing a study group with Ryan Hoegg, and we'll be using MUnit to simulate bad things. There's a quick couple of things to go over real quick. There's the code of conduct. If your mom and dad would have told you not to do it, then don't do it. Pretty easy.
Or if my mom and
Uh,
dad either would have told you not to do
hey,
it.
that too. That too.
Yeah.
And then you can find all of our previous, study groups and everything else either on YouTube or our Integration Quest site. So if you missed one, you want to revisit it, or you want to rewatch this one, it's all going to be found there.
Yeah, I found out some people they watch our they watch one of our videos and they on YouTube, so they might be watching this one right now, right?
Right.
And they don't know that we have like 50 other ones. So it's a good
Oh,
thing
wow.
to show that library thing.
Yes.
Mhm. Yeah.
And then just a quick little bit about Ryan. He's the CTO of Integration Quest. He's been a MuleSoft certified trainer since 2013, 25 plus years in software development, 15 years in the MuleSoft ecosystem. He's a MuleSoft integration platform architect, integration associate. He started all the way back in 2010 with MuleSoft, and active instructor with Trailhead Academy, speaks at events. I mean, he's very, very involved in the community.
Yeah.
And I'm going to go ahead and stop sharing and let Ryan take over.
Basically, that slide said I'm very, very old too. Thanks for that.
Oh, yeah, of course, of course.
Yeah, 48 years in computers. Not really. Jeez. Oh man. Yeah. Okay. I was telling Jacqueline before the before we got started on here that I'm just going to start with a blank project. I know some of you may not do. This might be the first MUnit study group you've attended or watched, and this is not going to be we're not going to only stay to basics in this one at all. We're going to do some advanced stuff, but I'm going to make it approachable for the basics. So bad things. So thinking about a Mule application and why you might want to use MUnit, I could start with a couple of stories about things I've had to troubleshoot in existing Mule applications. So I just want to paint a picture of why I do MuleSoft all these years. It's really good at building like these little integration apps that you go set up for a company, maybe your company, and then you install them and you put them in production and they just run for years, right? And they're supposed to just work, and there's not a screen and there's no user interface and there's no mobile app. It's just this invisible little widget that makes your company work. That's what we're making with Mule. That's what it's great at, right? Until something goes wrong. And, when Mule's in the middle, people are, well, at first I used to be annoyed. They're like, what's wrong with Mule? I do like it though, because you can go into, Runtime Manager and you can go find out what's wrong with actually integration. And even if it's not Mule that's broken, it's able to tell you what is broken. And you can go fix whatever's broken. It's kind of like the plumbing or the electrical in your house being broken. It doesn't happen every day, but when it happens, it's a serious thing, and we need to make some use of it. So this MUnit session isn't going to be about the monitoring, even though the monitoring and the alerting is a very useful thing to do when bad things happen. I want to go another step up today. This is about making Mule do. This is about using MUnit, of course, but to make Mule help when bad things happen, not just to make Mule tell you when bad things happen. Wouldn't it be nice to actually have Mule fix it when bad things happen? Hey, right? That's better, right? So I want to use MUnit to simulate one of these bad things, and you can probably imagine some of the bad things that happen when an application is running in a real production environment. So I don't know if you want to put in the chat some of the bad things that are that happen to these poor integrations while they're just trying to hum and run behind the scenes for weeks and months and years. What are some bad things? I don't know what are some of the systems that your integrations are connecting to. Give me some of those. We can imagine some of the bad things. Someone changes the credentials to the system you connect to without telling you, or the credentials expire, or What happened last year with credentials. I love this whole thing with credentials, right? Because we want to be secure with integrations. Salesforce has deprecated their the certain kind of authentication that MuleSoft used with client ID and secret that was, or no, with username, password, and security token that we've had in our trainings for how many years, right? That's going away. Not yet, but it's going away pretty soon. And when it goes away, that's going to stop working, right? Jacqueline's connected to SAP and Coupa and Dayforce and Salesforce and Azure Blob and FTP and SharePoint and your customer's Fusion middleware, which it has its own stuff, right? And all of these things, these are application layer connections that ride on top of a bunch of other layers, which I didn't have the diagram ready because I wasn't planning to do architecture, but I'll do a little. I can't help it anymore. You know, I'm in my 40s. I'm at an age where I kind of always do architecture. So we'll do a little architecture mixed in here, because the connections at the application layer are many and varied, right? And the application layer is a layer of what we call the OSI model of networking. It's up here, right? So when you're talking about Salesforce and Oracle and SAP and Workday or databases, like the application layer is what's the point of everything. That's what. But in order for the computers to talk to each other, application layer, we got all these layers down below where bad things can happen, right? So the physical layer, you can imagine some bad things that could happen, right? Somebody could stop the actual complete other service, right? Or they could unplug the network cable, right? Power could go out, right? Bad things can happen way down here in the real world, and those are going to look to Mule a certain way, right? If the power goes out, well, if the power goes out on Mule, it's going to look like a sudden stop, right? If the power goes out on the thing MuleSoft is talking to, it's going to be apparent at a higher level of the network stack, right? And as you work your way up the stack, you get different bad things that can go wrong, right? You can have what they call switch cycles at the data link layer. That would only happen inside a data center. You could have routing problems at the network layer, or firewalls will block you here, and so you can't get to a certain IP address from this other IP address. You could have connection refused, or you could have connection timed out. That's the transport layer, right? Or you could, the other side of it, you could have failure to acquire a port, right? And then all the way up to the presentation layer, you could have an SSL certificate be expired or something like that, right? You could have DNS be unresolved, right? So there's all these locations in the network stack where bad things can happen. And Mule is just going to know at the end, right? If we don't do anything, it's just going to know that, hey, I couldn't talk to Salesforce, right? I tried to talk to Salesforce and something went wrong, and sorry, right? And it'll try to tell you what went wrong. It'll print out the best it can from its error messages in the log. This is what went wrong, right? Bad thing happened, right? It's like screaming, something bad happened, right? We can simulate those bad things. We can make a bad thing happen for real, see what it actually does, and then make MUnit pretend like that happens, so that then we can actually code our application to do something better than what it does now when that bad thing happens. And I was thinking ahead of this call, what I want to do, like connection refused. So let's try a couple of them. Here's what I'm going to do. We're just going to make a flow, right? And I'm going to have this flow start with a scheduler, and I'm going to make the scheduler happen once in a while, a very long while. Once in a long while. There we go, right? And then we're going to have it, let's just say we're going to have it try to call an API, right? So call REST API. Now this could be a database connection. This could be a Salesforce connection. This could be SAP or Azure Blob, or I'm just reading the chat here. Jacqueline, thanks for giving me something to work with, right? Or whatever. I'm calling something. My flow needs to go do something, right? And whatever it needs to go do, might work or might not. So let me actually go put this at something that will work the first time around. So we'll make the host be https://mulesoft.com. And actually, let me I had an easier one going. Let's see what happens there. I'm going to use MuleSoft.com and then I'll change it to something a little simpler. There we go. And we're going to go just get slash, right? And now we're calling. Good news, folks. REST and websites are made out of the same stuff. So if I just go to a website with this, it'll be like a browser going to a website. So for now, that'll work. Yeah, there we go. Oh, this is a cool one. I found one over here. We'll switch it to that one in a minute. So we're going to go to MuleSoft.com and we're going to see what happens. I'm going to log what happens, right? There we go. And we're going to say, and I'll change this later though, info level log, and it's just going to be flow 1. There we go. And we're just going to log the payload out. All right. And so if I run this app for real, nothing bad's going to happen for now. So you didn't come to this study group called Using MUnit to Simulate Bad Things to see things work, did you? You came to see us break stuff. Well, actually, why did that break? Unresolved address. Well, I got a bad thing the first time because I misspelled something. So that would be what it looks like if we have a DNS failure. Let's get a good thing first. So nobody caught me on that one. The problem is I just need to put the host in the host, not the whole URL. There we go. Let's try that again. And what I'm going to do is break it a bunch of different ways. And we're going to see what it looks like when you break it a bunch of different ways. So here's where it worked. And MuleSoft has a very long web page. So it logged a whole bunch of HTML. Oh, too much for my console, which is why I went and got this one. So luckily I can use AI to help me locate useful test APIs. There's one called JSON placeholder.dev, right? So we're going to change the host to that and press OK. I'm just going to see if it works. And then we're going to make the path be /todos/1. So we're going to go get the first to do from whatever that website is and see if it's a little shorter than what MuleSoft's web page looks like, right? So we've got a little API now that, or a little app that calls an API. Nothing happened, unless it happened early. Starting flow 1. Why didn't I see it happen? Let's try it again. I'm going to stop. Let's actually do this. I'm going to try it in a browser first. I should get it's just spinning. JSON placeholder.
It's .com, not .dev.
Is it? Well, this is type of code. Did you try it with .com?
I've always used .com, right? Oh, type of code. Okay.
Well, I don't know if it is. I'm going to try it. I will try what you said, though. Where does it say post/1? Well, I'll just change it to that because
yeah,
hey, whatever.
That's what I would do. Like typecom. Typecode.com.
Yeah, let's change it to that. See, AI told me the wrong host name, and then I got a timeout. There we go. Apply. And then I need to change this to say posts. There we go. Save. And run. I'm a big fan of experimental learning in Mule. So there we go. So we're calling a REST API and it works great. I'm not so sure about the contents. It looks like fake Latin. Anyway, now let's break it. the whole fun part is breaking it, right? So we've already seen one of the ways it can break. And so I'm going to set the response timeout to 5 seconds. Is it seconds or milliseconds? I think it's milliseconds. Well, the help isn't too useful. I'm going to have to look that one up, actually. I want a short response timeout here. So we're going to go to connectors, HTTP connector, reference, and operations. And we'll go to the request. And it has a response. Where is it? Timeout. Oh, no. Well, it doesn't say if it's milliseconds. I'm going to put 5 first. And if it times out really fast, then it must be milliseconds, right? I think it's probably milliseconds.
I think it's milliseconds too.
Well, 5,000 seconds would be a long time. Anyway, I'm going to do that, and we're going to make it be a API that is not answering the host name. So we'll do .com with another M on it. So we're going to get a DNS lookup failure this time. Broken. There we go. And see what happens. All right, HTTP GET failed, and there's the host name. Connection failed, unresolved address. So what you start to find out is that you can tell these different types of failures apart, but they have an Mule error in common, right? So it's an HTTP connectivity error, but not all connectivity errors are the same, right? Let me think of connectivity errors are all very similar, though, in that most of them can be retried. A DNS failure is unlikely to work unless you have a very long retry cycle, right? And then let's do another one that's not going to succeed. I want it to look up but not succeed. I know what I'll do. Okay, so let's say I want it to look up but time out, right? I'm going to try a completely different port. So we're going to take broken off of here, but we're going to put the port be 4443, right? Which they're not listening on, right? So I'm going to save that and see what happens. And it's taking, I hope, 5,000 milliseconds, Whitney. I don't know if it's taking 5,000 seconds. I'm going to try it again. I'm going to try it. See, the thing is, if I put a really short response timeout on it, it'll definitely tell me that answer faster. So I changed it from 5,000 to 5. And it's like it's not running the scheduler when I do it that way. I think what it's doing is it's making me restart to run the scheduler again, which I'm surprised. I thought it would run every restart. But let's see. Deployed. Oh, the response timeout is after. Okay, so news. I did not account for that. There's more than one timeout on an HTTP request. This is the response timeout. There's also, is it on the connector? There's a connection timeout, which is what we're running into now. Connection idle timeout, or where's the other one? I just want the client socket properties, edit inline. There it is. So I have a 30-second connection timeout. That's not too bad. We can shorten that if we want. But after 30 seconds, then, if I'm patient, do I want to gamble on it. So that's at 11:22 and 47 seconds. My clock says 11:23. Should have hit it already. Don't think I'm hitting that one. I'm going to change the connection timeout to 3 seconds. Oh, no, wait. That was 30. Was that 30 seconds? 11. It was 60 seconds, wasn't it? Connectivity. Connection timed out after 30 seconds, but it sure seemed like it took longer than 30 seconds because of the timing. Look, it started at 11:22:47, and that happened at 11:23:48. Huh. I don't know why we got connection timed after 30 seconds, 60 seconds later. However, we did get a connection timeout, right? So that's the OSI model in action, right? We did not get, so a response timeout would have to get all the way a connection established at the application level, and then send the request, and then get a timeout of the response. We didn't even get the connection in the first place, so the phone's just ringing and ringing and ringing. We didn't even get to say hello, right? So way down here at the session level, it timed out. Like, so it's a little earlier in the exchange where it failed, right? We got this connectivity failure. So for this demo, I'll probably shorten that to 10 seconds. There we go. We're going to have a 10-second connection. Oops, that's the idle. I need the connection timeout, 10 seconds. Yeah, there we go. And look at all these other good stuff. I'll hit OK. And before I save it, we're going to fix that problem. So we've now seen kind of 2 bad things that can fail. I prepared another one for you. There is this cool website that I found through, actually I have to give Amazon credit. Sorry, Salesforce. This was Amazon who told me about this one. It's called badssl.com. So sometimes what I'm running into in production is everything works fine, and then suddenly a certificate expires, and then everything's broken again. And there's a lot of ways a certificate can be bad for an HTTPS connection, right? So they have a handy bunch of different DNS names that have all these different certificate problems. So you can go see one that's just like whatever you're seeing in production, and then you can make an MUnit test, or first you can just make a real test and then do an MUnit test with all of these different SSL problems. So I'm going to do the one we all run into most. Expired, right? So your connection is not private, certificate date invalid, and it tells you, hey, it expires 10 years ago, and the current date is right now, and it tells you all about it, right? So we're going to use that and see what happens. So expired.badssl.com, press OK, and see how that works. Whoa, that failed pretty. Wait, why did it get a timeout exceeded? 11:26. It started 11:26:34. Did I fat finger something in my timeouts? Let me go back and edit them. Connection idle timeout. Connection timeout 10 seconds. I don't think that was. Well, let me turn this. I'm going to turn the client socket properties back off for now and see if it changes something, because I'm trying to show something else. But I think I had the wrong. I think I did not have complete client socket properties. It's still timing out. It's timing out super fast. I know what it is. I think I left my response timeout too short. Remember that? Whitney was right. Is this the Whitney was right moment? There you go, Whitney. High five. There we go. Let's put that back to 5,000 milliseconds. We're still getting nope. Now we're not getting a timeout. We're getting all this nastiness that we always see in our production logs, right? PKIX path validation failed, and it's saying SSL handshake exception, all this good stuff, right? So if we go to expired.badssl.com, then we're going to get an expired. I think this is the one I'm going to do in MUnit. I'm going to do an expired SSL certificate. The reason I want to do this one in MUnit is I find a lot of use in MUnit in simulating unusual bad things so that I can build my application properly for things that are not that common, but when they hit us, it's going to be really bad, like an expired SSL certificate. So let's go make an MUnit test, and we'll do a, like I promised, we'll do a bit of an MUnit crash course as we go, right? So you can just make a new MUnit test and source test MUnit, and we're going to call this one the resilience tests. And I do actually use this real name. Now, sometimes I'll do more than one different test file. So a single file in source test MUnit has the name MUnit suite. And a suite is a file that can contain many MUnit tests, but it runs as a single unit. So when it runs, all the tests inside run, right? So we're going to use this resilience test file. And if I made more than one test, which I don't know if I'll have time today to do more than one, then all the tests in this file would run, right? So this suite is a unit of execution. Inside an MUnit suite, you put MUnit tests. So this is a test. You can also see there's 4 other scopes you can add: after test and before test. So if I have 2 tests in here, 1, 2, then before test will run twice. It'll run before test and then test 1. And it'll run before test and then test 2. If I put after test, then it'll clean up. You can use it after each test to go whatever you need to do. Now, there's a lot of different kinds of unit tests. I have a couple of other videos on different types of tests. Resilience tests are my vocabulary. I like to have different classifications of my tests. Resilience tests are the ones that make sure that the application is adding some kind of value when something goes wrong. So I wouldn't put a logging thing in a resilience test. I wouldn't put an alerting thing. That's all about telling people, hey, can you come fix me? I'm broken, right? A resilience test is where the test tries to take care of its own problems, right? I'm not going to say I'm broken yet because I'm going to fix something myself, maybe a retry or a fallback or some kind of way that the Mule application tries to recover when something goes wrong. So I'm going to make a resilience test for this bad SSL situation, right, of an expired certificate. So if we think about what you would want the application to do in the case of an expired certificate, you have some choices, right? And I might ask you to start thinking about if you wanted an application to be resilient in whatever you think resilient means in the case of an expired certificate, what would it do? I'll let you think about that for a minute. I have an idea or two of a creative, I'm not sure you'll all agree with it, but a creative thing we could do in this case so that, we don't break things. We have production users depending on our application, right? So I'm going to name my MUnit test. This is going to be expired downstream certificate should whatever. So when I name a MUnit test, I want it to describe what the test is about, what scenario, what context this test is creating, and then what my test is claiming the application should do about it. I really want the test to take a side, to have an opinion, right? So this one's going to say whatever we think should happen when the application encounters an expired certificate. What I want you to notice, and I'm inspired by this, I want you to notice that the application doesn't currently do anything about it. Right now, the application just crashes, right? Or it doesn't crash, but it just logs an error and doesn't work, right? So that's not maybe what we're saying we would like to happen. And so you can, one way of designing application enhancements is test-driven application enhancements. And this is not from MuleSoft. This is from long old software traditions. You can write a test for the way you want things to be. And then you run the test, and of course it's going to fail. That's red. You're going to get red, and then you're going to get a green, and then you're going to refactor. So there's a cycle: red, green, refactor. Red means that the test fails for the right reason. So first, I'm going to express what I want the application to do using an MUnit test, and the application doesn't currently do it. So of course the test is going to fail, and that's a good thing because I'm showing that what I want the application to do does not match what the application does do, and then it's go ahead and make the application do it, right? So any ideas? What could an application do? Let's say it's been running for 6 months and today the certificate expired. What are some options we have that the application could do when it runs into an expired certificate? Send an email to the support team. Yeah, it could. Oh, now I do like that one. I want it. That's today. I want to do resilience. Sometimes I want to do supportability, and that is a supportability feature, right? So there's one. So one thing the application should definitely do is tell the humans, right? Help, right? Something's wrong. That's a good feature. Today, I want to test something about the application taking care of the problem without any humans. So what are some ways you can imagine an application could do what it's supposed? Let me add a little to this. Let's say
Is there
this
a backup
application,
site?
we could do a fallback site. Okay. And that would look like, what would be a backup? So you'd have to provision a fallback, like you have a different region or something, or different. Yeah. We could call a fallback. Here, let me put that. So one option, resilience options in case of expired downstream certificate. I'm writing it in the chat. One, fall back to an alternate downstream API. That is a very good one. Any others? Let me add something here. Let's say what it's supposed to do. It's supposed to call the API, and then it's going to upload whatever it got to SFTP. That's some kind of a legacy thing, right? So we're going to call the API, and then we're going to write to an SFTP server. So I want that file to make it, right? So Whitney's would look like this. I would put a try. I would put a on error continue. And then I would do whatever the backup is, right? Another HTTP request in there. And it would have to catch the right error, right, for that one to work. What else could it do? How long does it take? Let's say that we did Oha's idea and we're going to email somebody, hey, the certificate's expired. In your experience, when you finally tell somebody the certificate's expired, how long does it really take to get it fixed? A day for Whitney? That's you got to. I'm want to join your team. That's. I mean, if it's a day or less, I'm very happy. I'll tell you. So retries, I would say retries are probably not the right resilience pattern here. So let me put that in the chat though. Option 2 is retries, but we would have to retry long enough for the fix to happen, right? And retries for a day are probably not acceptable. What else could we do?
Are you thinking a self-signed cert? That's not good, right?
I mean, we could ignore the problem, right? And just call it anyway. Right now, there's a limited risk in that, right? With an expired, so if it's there's different certificate problems, right? Let's think about the actual security context here. We have expired certificate, we have wrong host, we have self-signed. These are different kinds of certificate problems, right? If you got revoked or wrong host or self-signed, you should be on high alert, right? Because probably you've got a actual cyber attack happening, right? Expired means something else, doesn't it? I mean, when you run into think of all the times in your career you ran into expired certificates. Was it a cyber attack ever? Any of the times? Not for me, right? It's just somebody didn't take care of it in time, right? They needed to go take care of it. So then we call them and then they fix it, and there wasn't actually a cyber attack, right? So the risk for a short time of accepting an expired certificate is lower than it would be for some of these other certificate problems, I think, right? So I'm going to put in the chat another option for that one, right? If you think clearly about it, right? Another option is expire for a limited, or ignore the expiration problem for a limited time, for a short grace period. How about that? We'll give it a grace period. And as long as you get your CISO to sign off on that, what you can do is you can get an alert and say the certificate expired. Somebody can go fix it, and the application can ignore it for a little while. Now, I kind of led the audience on this one because I feel like that'll be a fun one to do. How can people don't realize you can make Mule do stuff like that, right? We could make it fine with it, but just for a little while, right? Just until the expiration is old enough, right? But that's going to take some fancy programming, right? So, if I want to look at the error that I got, does it even say the date in there? There it is, not after. So that date is from 2015, right? So the actual certificate is way over. So like we should not ignore that one. Somebody should have fixed it by now. If they didn't, we have a problem, right? So that one's not going to be any good. But if we did one that was like expired yesterday, maybe we could do something about that, right? So I'm trying to make this an MUnit study group. And so I'm going to begin by simulating any certificate error. And then we're going to see if we can actually put in a certain not after so that we can force Mule to have a certificate that is maybe 1 hour expired or a certificate that is 2 days expired, and we can tell the difference. Wouldn't that be cool? Right? So we're going to do that. We're going to make Mule do this error, right? And what it looks like at the bottom, you just use the logs. It's an HTTP connectivity error. So we're going to zoom in first, and we're going to do a little MUnit what was a cheat, crash course, right? MUnit tests have 3 scopes. They have an execution scope, they have a behavior scope, and they have a validation scope. Let me hit stop. There we go. Execution is where you tell Mule what you want it to run. And so you have to simulate whatever actually ran. So if this was an API, you would have to simulate that flow starting. In this case, it's a scheduled job. Well, in MUnit, when you run MUnit, the flow sources are disabled by default. I'm going to show you that. In an MUnit test, I clicked on the test title. We're going to say should warn and not error if expired downstream. Let me do it like this: expired downstream certificate less than 2 days old, expired, should warn and not error. How about that? There we go. So we're going to make that scenario, right? And not to say that you should have this policy for your own resilience tests. I'm just trying to show you the kind of thing you can make a resilience test do, right? I can make a 2 day expired, I can make a 1 day expired certificate anytime I want, right? So we're going to make the test do that. This test has at the bottom, it has an enable flow sources set up. So I don't know if I can zoom it. I probably can't zoom it. Enable flow sources. There we go. I can zoom it if I do this. There we go. Right? That means that by default, no event sources in Mule are turned on. So when MUnit runs, all the event sources are turned off. No schedulers are going to run, no HTTP listeners, no database listeners. Nothing is going to just run by itself. You have to make things run. But you can override that in the flow. So we're not going to override anything. We're going to leave 0 flow sources enabled, and we're just going to call the exact flow that the scheduler calls, right? We're going to use a flow reference, right? So I'm going to go do a flow reference in my execution section for flow 1. There we go. And now it's going to run the flow. Now, what I wanted to do is I wanted to have a HTTP connectivity error when I'm going to show you a bad way and a good way. I think I have time. Oh, I want this API call not to work, right? So if I just run it now, here, I'll run the suite here. We're going to run this test right now. So far, it's going to launch Mule for each one of the tests. If I had 3 tests in this file, it would run 3 different times Mule. And then it's going to run whatever this execution test section has. And then it's going to check whatever's in the validation section, which I don't have anything right now. What did it say? It says HTTP connectivity. Oh, of course it does. Because I left the bad host name in. So let's go fix the app, actually, because it wouldn't naturally have a bad one. I'm trying to make it simulate bad things, not actually have bad things. So JSON placeholder dot something. What was it? typecode.com. There we go. Let's try that again. And you can just, so on the left side, this is your MUnit runner, and it allows you to just run, you can selectively run one MUnit test at a time, or you can run all of them. And I apologize. I really thought I was going to try to do at any point code builder here, but I wanted to get deep into MUnit, and I'm not that good at the code builder MUnit interface yet. So I wanted to, there we go. So it ran the execution section of my test here. And it also ran whatever is in my validation section. I just don't have anything there, right? Now, what I want this to do is warn and not error. So my validation section needs to check that I'm warning something and then I'm not erroring anything, right? Now, not erroring is pretty easy because if it does error, I'm going to, well, we just saw what happens. You already get a red test, so that's fine. But how do I check if it warns, right? Well, that's actually pretty tricky. MUnit's not so good at testing log lines, right? If I wanted to test that a certain logger came out, it's pretty hard to do. Here in the room, we've got Rook, and Rook and I were talking about this on his project recently. That's one where I'm actually going to use something I told him I never use, right? So what I'll do is I will add an error handler here, which is for a custom error, which I don't even have yet. Sometimes I have to add a little code to get this to work. So I'm going to add a validation module, and I'm going to do an is true validation right after the HTTP request. For now, I'm going to end up moving it into a try, but for now this works. And I'm just going to test if false is true. So if true is true. So nothing's going to happen here. But if this one ever fails, what I need to do is define the error. So this is going to be expired cert. This is going to be recent expired cert, right? So I'm going to make an error for what I want. And that way now what I've done here is this is going to be cert expired recently. There we go. Just so you can see what it is on my screen. This validation is going to go away later. I just need the application to actually declare the error. That way I can catch it down here, right? And I'm going to put on error continue down here, and we're going to catch that one. There it is. It's an actually named error, and I can put a logger in here, right? And this logger is my warning, right? And this is what's hard to assert on is how do I assert my how do I assert that my right loggers happened, right? So certificate has expired, and we are still in the grace period. I'll probably write a better message for my poor sysadmins than that, but I'll probably give the expiration date, whatever. Anyway, I'm going to warn that, right? And what I want to make sure is that event processor has been reached, right? And so this is something I rarely use in MUnit, but today this is a good time to use it, right? So, what happened here? Where did my module go? Yeah, whatever. I don't know why it's not showing me my MUnit tools. Close all. Come on. Anypoint Studio, help me out here. There it is. It came back. I had to get MUnit tools to show up here. There's one called verify call, right? And so there's 3 different MUnit tools that allow you to kind of look into what happens during the flow itself and then either measure something or change something. It's like it allows you to intercept stuff when the test is running only, but not in real life. So we're going to run the test, and we want to make the test capture some information or change how the application works just for the purpose of the test. This one's job is to tell me if a certain event processor actually happened, right? So I'm going to name it verify call that the grace period warning logger was what we verified, right? So I named it like that, and we're going to pick processor, and we're going to take that warn, and I guess what I'm going to have to use is level warn and category resilience. I really try to avoid matching on these doc ID and doc names unless I can't think of anything else. The problem is if I match what these attributes do is they tell MUnit which event processor to watch for, right? And if I'm too specific, then when somebody else comes along and changes the code, my test will fail for a bad reason. So I'm trying to build a robust test, right? But the problem is if I match on the message here, then if anybody changes the wording of the message, the test will fail. Now, if I step back and think about that, that's kind of a minor problem. Like if you come along behind me and change my log message, it might be okay that the test fails. Then you'll just go fix the test. I mean, you were the one who reworded the log message. It's a little bit brittle. You know, I don't like brittle tests, but so the other option is I could match on the doc ID, and then it'll always match no matter what the log message is, right? So it's a design question. You can decide you rather match on the message or match on the doc ID. I'm going to match for this case on the message. So I'm making sure that we get a warning message with the category resilience and this exact message. And I'm trying to say for this study group, I think that is up for debate, whether you would want to match on message or doc ID. That's kind of there's trade-offs both ways. I'm picking message, but I'm not saying that's always best, right? So I'm going to match on the message this time. And then let's run it, and we should see a failure, right? It's not going to do that, right? So I'm going to run again. And the reason it's going to do a failure is this validation is checking if true is always, whether all it's doing is checking true. I just needed to define the message. So we have nothing that's going to actually reach this warn, right? Nothing's going to get there yet. I haven't done any code that's going to get there. So now we get a failing MUnit test, and it says it's failing because it expected 1 but got 0 of the warning log. Okay, so we want to get to that warning log, right? So now we're, the title of the study group is let's simulate a bad thing from happening. So what I want is, for now, only when I get, so I'm going to get rid of this is true anymore, right? I'm going to save it for now. Only when we fail with an HTTP connectivity error do we want the warning to happen, right? So I'm going to wrap the HTTP request in a try. What happened? Did that Anypoint Studio did something fishy here? I'm going to save. Okay, there it is. My graphics did something weird. And I'm going to add, for now, an on error continue. Although if I had 3 hours for this lesson, this is going to get way more complicated. Right now, I'm just going to be real simple. And we're going to match on HTTP connectivity because that's what we saw when we actually had the real problem, right? In HTTP connectivity. And I don't need, well, I'll leave log exception on. I can turn it off later. Anyway, for now, I'm just going to have it raise that recent expired cert, right? So later I'll add the validation, but right now I'm just going to raise error, right? If we get it, I'm being too loose right now, right? This is going to say app recent expired cert and say the certificate expired at XXXXX, because I'm going to fill that out in a minute. I want to see if we can capture that, right? And I like to put this, does it show me? It doesn't show me, right? So I'm going to put this in the doc name also. Shoop, shoop. There we go. Save. And so now, do we expect green or red? Is it going to pass or fail if I run it? What do you think? Is it going to reach the warning if I run it green and it'll pass? Or is it going to not reach the warning yet if I run it and it'll keep failing? How does it get to the warning?
See your MUnit again?
Yeah. Very simple right now, right?
Don't you have to mock?
What's that? Yeah, we have to mock, but we haven't talked about mocks. Yeah. If I don't mock,
How is it?
this
How
is not
going
going
to
to
fail without your mock?
It's not going to get that error, is it, Whitney?
Yeah.
Right. So we have to make the error happen. That's the simulating bad thing. You're right. So if I run it, but when I'm doing unit testing or any testing, I try to be very empirical. So we just predicted that we're going to still get red, right? So I'm going to run it. What I love about tests is you can always just run them again, and be extremely, and anytime what you expect isn't what you see, you stop. And you say, wait a second, and you understand. Why didn't it do what I expected, right? And every time you improve this test to have a little bit more of your expected scenario, you get closer and closer to what you want, right? So this is really how I think through writing tests. I'm failing because we never reached the logger. Whitney did that in her head, and she said, why didn't we reach the logger? Because we never had the error. Why didn't we have the error? And Whitney already knew, because I need to make the error happen. Well, MUnit has a way to make errors happen, right? So we're going to use this mock. That's what a mock does. I'm going to drag it in here. A mock is kind of like verify call, but a mock, you point it with a pick processor, just like before, right? You point it at something, and instead of just checking, the mock actually influences. It's like it can actually change what that thing does, right? So we're going to take this call REST API, and we're going to match it on method get, path posts, and that config ref. That's specific enough for me, right? And we're going to say anytime with the mock that the MUnit sees that particular processor run, the mock gets to take over, right? So this is the API call. We're going to mock the API call. Now, I haven't said what we're going to mock. All I said is what we're going to mock. What we want to control is what happens when it mocks. And just this week with Rook, we ran into, there's twists about this, right? So you can see, you can control the error object that comes out, right? So at first, I'm going to do this in the very innocent way. Like, try to take what the Mule is telling me to do. I'm going to make an HTTP connectivity here. Yeah. And we're going to just make the error happen the way we want. Oops. Save. So what I did was API call should give expired certificate. And I'm not going to write the rest because I haven't done the rest yet, right? All right. And then we're going to run it again, and we expect green or red. Always make a hypothesis. Right? What I did was I made it return an HTTP connectivity error. And if you think red, you want to think, why is it red? If you think green, that means you think we've done everything, right? So what we're trying to do is see if we get down here. I'm going to run it now. I think green because I think I've done enough to get there. And I'm always willing to be wrong. This is like real science, right? You just make a hypothesis. You prove your hypothesis true or false. You go to the next step, right?
And I see your verified call.
Yeah. Yeah. So I'm picking a logger with the, so it's checking if we reach this logger. This logger at the bottom.
Okay.
Yeah. I think we did it. I don't know. Let's run though. Let's see. And there's really, it doesn't matter about getting right. Because guess what? With testing, you just run the test and it tells you if you're right. That's great. Testing is very low anxiety, right? We got there. Great. So we got there, but we're not happy yet because this test says expired downstream certificate less than 2 days expired. I didn't make that happen. I just made some kind of connectivity error. So I got to get a little closer, right? I got to make it be an actual expired certificate error, right? So I'm going to go back here. I'm going to rerun the app without MUnit, and we're going to see what's different. This one worked fine, right? And then I have to go change the host name back to the expired.badssl.com. Save it. And then watch what happens. Okay. So now we're getting, oh, that's better. So we do get my app reach an expired cert now. But in order to get it, we have to get an HTTP connectivity. And we could check the message. See, the message says failed, PKIX validation failed. Also, there's cause by, right? So this is going to be fun. What I'm going to do, and I love doing it this way. I can work out a data weave expression to get all the way down to, I want to get, for now, I want to see that I got an SSL handshake exception, or maybe even, does it tell me? Certificate, look at that one. Wouldn't it be nice to go all the way down and get that certificate expired exception, right? We can do that, guys. We can do that. So here's what I'm going to do. I'm going to rerun the app in debug mode, which all of my people in this study group that know me are shocked because Ryan never uses debug mode. This is a good moment for it, right? Debug history, MUnit bad things. This is when I want to see exactly what Mule sees when the certificate is expired and see if I can use the data weave expression to go get to that error. Oh, I may have to extend my response timeout, but here we are. And then I'm going to step. Boom. All right, let's see what we can get here in the expression. So error dot cause. Let's see what that has. Okay, so there's the SSL handshake exception, right? And the cause has fields in it. So if I just wanted that, I would get not type is connectivity. If I did error.cause.type, I would get connectivity. That's not enough, right? Error.cause.message. I'm not thrilled with that one. Error.cause.accept. Is there an exception? No, there's not an exception. We got to find what's in there. Error.cause. I could do keys of error.cause. Okay, so I've got localized message, cause type message, stack trace. I guess I could go into stack trace. That's stack trace. Okay, there's 0 elements in the list, so that's not useful. And error.cause.cause gives me something else. We're getting closer. Let me do keys of that. Error.cause.cause. See, I still have all these things. Message. See, I'm not getting the exception name, so I don't know if I can get certificate expired exception, even though it shows it. Let's just do error.cause.cause and see what I have. I still have SSL. So I'm already getting SSL handshake exception, which isn't too bad. This one is the validity checked failed. So I'm one more away. I want to get all the way down to the third one.
Do another
Right.
dot cause.
Yeah, that'll get me to that last one. But unfortunately, I think that one.
Oh.
Oh, do I have to go one more? Oh, am I in a loop here? Let me do 2 dot causes. This is already the validity check failed. Maybe this one has a stack trace. Yeah, this one has a stack trace. All right, so I'm in error.cause.cause and I have a stack trace. Create SSL all the way down the end. Now I need to get the one. It has a cost by. Let me do type of this.
Is it 45? Because I'm looking on the console and it says 46 more as the last end.
So you think this says 41 here.
Oh.
Yeah, 46 more lines though.
Oh, that's lines. Okay.
Yeah, what I want to get to that date, right? So I'm going to have to get all the way down there. Cert path validator exception.
What happens if you go in 40? Like
In the array?
Yeah, an array.
Well, let's do this. I think that's too specific, but I can find my way there. This is saying thread run. So it's like it's on. So I don't want the stack trace is what that means. I need to get to the next exception, right? There's a backtrace, the depth. And if I do, unfortunately, data weave may not let me get here. So there's 2 ways about this. And for this lesson, okay, so what I wanted to show is one way to make this error happen is to create exactly the message you expect to see. And this does work, and I've done it before, but it's not the way I would do it this time, okay? Here, what it does is it ties you to this exact version of the connector in Mule. So it works for now, and as soon as somebody updates the connector, this way of simulating the error kind of gets overridden by however they make the connector improve, right? So what I was trying to drive at is there's kind of a very precise way to simulate this error. And if we kept going the way that Whitney and I have been going in here, digging into data, we could find our way to this exact certificate expired exception, right? And and then we could dig out what that certificate is. What I'm going to do instead is another way to simulate the error. So I'm going to hit stop, and because I wanted you to see both of the methods available to you when you might want to work on these kind of errors, right? So the other way you can mock an error is, instead of mocking the exact error that comes out, right? I'm going to erase that. Under then return, there's a then call, and you can call a flow, right? So let's do that. Let's do HTTP. Let's make a flow in my test. So not everybody knows that you can do that. You can put a flow in your test, and this is going to say force recent expired certificate in your test, right? Flow, right? And then I can have the mock call that flow. And the why I would do that is I can use a real error in my fake error, right? I don't have to trick Mule into making exactly the right shape of an error object. I can just do an HTTP request in here to the expired.badssl.com, right? So I'm going to create a now, there's a couple ways to do this too for your tests. There's always a danger in what I'm about to do, right? I'm about to use expired.badssl.com. Well, now for government work, that's going to work, right? Because that's out there. You can trust it. Anytime you tie your test to somebody else's software, you are now incurring a risk that they might break your test instead of you. So if Amazon ever takes this badssl.com thing down, now my test is vulnerable, right? So there's another way to do it where you actually make a certificate in your app. It's just more work. So you always can be in control of your own destiny, though. That's what I really want you to see. How do you be in control of your own destiny? So I'm going to start with expired.badssl.com, right? And we're going to hit OK. And this request is now going to get whatever I want off of badssl.com. So this is going to be expired.badssl.com, right? And now I can make my mock call force recent expired certificate flow, right? And that just means that now, even though I fix my API, let's go fix my API back to what it's supposed to be. JSON placeholder dot, what is it? If you guys remember now, typey face or something?
Typeycode.com.
Typeycode. McBodie face. Typeycode.com. It was Bodie McBoatface, I think. That's another whole story. Said okay. Save that one. And now the code is pointing at a real site, but my test is mocking the API call, so it points at the expired.badssl.com, and let's see what happens. Hit the button. I didn't make you make a hypothesis first. Try to quickly think what's going to happen.
It's going to call the flow.
Oh, why did it fail? What did it say? Error, Mule unknown while running test. Let's go look at the logs. I didn't expect that either. We got the certificate expired. That's what I wanted. So far, I'm happy. Error. Error sending HTTP request to that. Validity check failed. But I don't know why it's a Mule unknown instead of an HTTP connectivity. Might be that the mock. I want to see the flow. So I don't know why I did that, and so I'm just going to debug and find out.
Is the URL wrong? I know you want to put the wrong URL, but is it wrong?
Yeah, what I'm not understanding is why it says Mule unknown there instead of
Like-
HTTP connectivity. But let's go find out. You mean not expired dot? I mean, I'll look at it while it's running.
Yeah.
That looks right. Okay, so we get here, we step, and now we're in that flow. We step, it raises an error. Step. Okay, we did make it back here, and the error is error.type. Huh, what is the error? Why doesn't it think it has an error?
I think you got to step next, right? Next processor for it to
Again?
pop up. Oh, it's unknown. Error type unknown.
Deserializable error implementation. Error type is unknown. What? Does it have a cause? It's like it has to unwrap it. See, the error.cause is what I wanted. No, it's not even, because it's not a... I wanted an HTTP connectivity. It's like the mock gave me the wrong error type, which I've done this before, so I haven't figured out what I did differently then. Do I have to... Let me check the XML here. I was expecting to force the HTTP connectivity today. Mock win. I have a then call and I don't have a then return. Sometimes the XML will be left with a then return and again then call at the same time. So what I want, and mocking errors is the trickiest part of MUnit, which is why I did this session. Let's see. Can I force it to match two? Do I have to put both? Let's see. I don't know if I have to put both of them on the mock. I'm guessing here. I don't remember how I got it to actually do it because we've already forced the real error. I'm still erroring out. Where's my error? It still says Mule unknown. See that? So I think it's raising the error and then because there's the HTTP connectivity now in the flow. So I wonder if I should use this as a spy. So my error getting raised over here is so I need to check one thing. Let's go to the MUnit documentation. I don't know if I have time to do spies today. I did mocks and I did verify call, but I don't have time to get spies in. MUnit processors, mock win, mock using then return. Yeah, the problem with mock errors is it allows you to say that let me see. This is MUnit tools. Return an error. Okay, you can put a type ID as that. Connection error, but I don't have the. Where is the custom payload? See, it says you can put a custom payload in here. That's just coming from your app. So the problem is it's only forcing the error to have a certain type ID. If you try to return an error type that is out of the scope of the flow you're testing, you get a Mule unknown error. But ours is in the scope. Oh, we can't force HTTP connectivity. That's what it is. I am not in charge of HTTP connectivity errors. If you create a mock error, then choose one of the following parameters to provide the trigger for the error in the then return. Type ID and then cause. Okay, this is better off. That's a pretty tricky way to do it. Okay, so we can use the cause to do it. So dynamically mock a variable, use then call. But then call can't do the error is what I think this is. So what that means is, unless I do set event, can set event put an error in there? I'm going to try one more thing in my flow up here. We're going to go to MUnit set event and see, can it set the error? It can set, yeah. Oh, but it's the same problem. It's the same problem. We only can do the error ID and the exception. We can't do the rest. I can set the payload here, attributes, error. And we're going to have to make an expression that produces the exception there. So that's the way to do it one way or the other. If I could do then call, but I cannot actually call badssl.com like I thought I could, unless we could try that. We're going to wrap in try. I'm going to try one more thing. This is probably the long way around. We're going to do a on error continue. And in here, we're going to do a set event. MUnit set event. Because the event, this has the chance to write the error just like the MUnit then returned it, right? So we're going to set event HTTP connectivity. And the exception needs to be error.cause, I think. I might be one level too deep. I might just have to do error. But let's see. Let's just do error.cause first and see how it goes. So am I still in debug mode? I don't really want to be in debug mode this time. Run. Now, did I get Mule unknown? I still got Mule unknown. Ah. Cannot read items. It's getting better. Cannot read field items. Whew. So there's the error. Error sending HTTP request. I was hoping to capture the real error and put it in the event with set event. Let's see. I'm going to do three things. We're going to set a variable here. Where did it go? I'm going to capture the error here like this. Error, HTTP error. Right? And then I'm going to put set event after. And then I'm going to take the error and I'm going to use vars.http error, but I'm not going to do the dot cause. So two things. I took it out of the on error continue and then override error. Let's see how it goes. It's got a shot. So the path to faking the error with a mock is you want the error to look exactly like what happens for a real SSL error. And I still haven't got it. So this is, oh, Mule critical is a little better. Okay, we are definitely getting changes here. Vars.http error should be throwable. Okay, so this is probably going to go back to the last one. So I got to do .cause here also. And we'll see if that even, there's got a low chance of, we're still back to Mule and no, most likely, right? So what we're hoping to do, though, what I'm after here, the design of the MUnit test, is I want the HTTP connector to give me the shape of the error object. I don't want to just get the current version, because like right now I'm on 1.11.3, and if I went back to the old strategy and got exactly what that error was in the right spot, and then they upgrade to 1.12, it'll break my whole test, right? So I would continue the design, the troubleshooting here until I got this error to be exactly what this is expecting, right? With the then return and the then call, so that I can craft the error exactly like I want. And then what I would want to do is have one more test. So I'm conscious of the time cast, and I know we're at 1 hour and 20 minutes. My plan here would be, and if I could even pose this as a YouTube challenge. If you comment on the video and you finish this and you send it back to me, we're going to recognize you on another study group. I want to make 2 tests. I want to make one where the certificate is less than 2 days expired, right? And I want to make another one where the certificate is more than 2 days expired. And so that way I'm kind of putting a fence on both sides of my design, right? I've got expired downstream certificate, more than 2 days expired, should warn, and error, right? I still want the warning, but now I want the actual flow to fail, right? So we want to see the flow succeed when the certificate is not too old and fail when it is too old. So I'm going to set that, given my time constraints for the video and the session, as a challenge to see who can solve it, and send it back, and then we'll present whatever it is on the next study group. The trick is we need to make this HTTP connectivity error match exactly on the certificate expiration date. And that means we need to make our mock give back a certificate with a specific expiration date. I want to see how you can solve that problem. There's more than one solution. I'm sure you guys can show me what you're thinking, and then we'll see if we get more than one design for that one. But you got to go. We have to honor our study group timing, so I'm going to leave it here as a challenge instead of a completed demo, Caston. And it's up to you, sir.
All right. Well, thank you everyone for coming in.
Do you have slides?
Yes. And come and see us next week with Trisha. She is doing VM connectors, and we are excited to see you guys again.
And I can't wait to see your challenges.
I like it. All right, I'm going to go ahead and end.